Okay, yesterday we have seen in the last lecture about the binary expression for the OR form and the IND forms. Okay, the binary expressions, binary equations can be expressed in the OR form and IND form also. Okay, then we have some postulates and also theorems. Okay, in order to simplify the Boolean equations, to get the simplification, we go with the binary expressions. These binary expressions can be simplified with the Boolean postulates and the theorems. Postulates are the some assumptions. We don't have the any proofing here. Okay, if you assume, okay, if any binary variable x is there, x can have the either 0 or 1. We don't have any proofing. Okay, we don't need any proofing here. And also one more postulate is x plus 0 is there. X plus 0 is nothing but the x only. That's we don't need any proofing here also, because x dot 1 is also x. Okay, the postulates whatever we're discussing here, these are the some postulates here. 5 postulates are there. One is the x equals to either 0 or 1. Second one is x plus 0 is the always x, and x plus y equals to y plus y x. Okay, and also x into y plus z equals to xy into y plus yz. Okay, this x plus 1, x plus x bar. Okay, x plus x bar is okay 1. X plus x bar is the 1. Okay, stop. Okay, x plus. These are the IND form. Whatever you are writing on the left side, these are R forms. Okay, IND forms are nothing but the dual forms. Duality. Okay, duality is nothing but the here the expressions are changing. Okay, interchanging the to IND R2. Okay, R2 and to R, and also we are replacing the operator cell IND to R to R, and also we are changing the binary values. Whether it is, if it is a 0, then I will be changing it to 1. If it is here x plus x bar is the 1. Here the replacing the x plus, okay, dot with the plus, you will replace with the dot, interchange the R2 IND here, and also we are changing, okay, here the changing the 1s to 0, 0s to 1. Okay, this is nothing but the dual of the first operation, first Boolean equation. Okay, these are whatever I am writing on the left side, these are the R forms, sometimes called as the R forms are nothing but the, here I use the plus operator. Just I am changing the R to IND. Okay, 1 to 0 here, 1 to 0 here. Okay, 1 to 0 here, and also we have the interchanging the values here. Okay, this is the associative law, x plus y equals to y plus x, x dot y equals to y dot x. Okay, these are the some postulates here. We don't need the any proofing here. Okay, already we are assumed here. Okay, this is the right only. These are whatever assumption we made, these are all right only. We don't need. But on the theorem side, x plus x equals to x only. Okay, we need the x. Already we done with the in the last class. These are the proofing also done. Okay, and x plus 1 equals to 1. X double dash is any complement of the complement variable is the original variable, and also we have the theorem number 4 is the x plus y equals to y plus z equals to x plus y plus z is the associative law. Okay, this is the theorem. This is the dual. This is what we are the De Morgan's theorem. X plus y o dash is the x dash plus y dash. Okay, these are the IND form. These are the R forms. Okay, dual forms are written the x dot x equals to x only. X dot, okay, plus operator is replaced with the dot operator. 1 is replaced with the 0. X dot 0 is the 0 only. Okay, x double dash we don't have the any dual forms. This one, particularly this one, we don't have plus 2 dot to plus here. Okay, just use this is what here the theorem of the De Morgan's theorem. X plus y o dash is equals to x dash dot y dash. Okay, here we replace the plus operator to dot operator, and also just we are making the same as it is. X plus y o dash is there, x dot y o dash, x dash y dash is there. Just I am changing the dot to plus here. Okay, this is what here the De Morgan's theorem. Yesterday we proved all the De Morgan's theorem, and these are all theorems are we proved here. Okay, today we will see the few more examples. I gave the in the yesterday class the assignments. Those are asked in the examinations on the last 2024 June. Okay, what are those? Yeah. Okay, we'll solve with the, while referring these Boolean postulates and theorem, we'll solve it. Okay, every time I will not call the theorems and postulates, just okay, first assignment was earlier, yesterday's class x dot, sorry, x dot dash plus y. Okay, this one is to be referred as the function x dot plus y, x dot x dash y. Okay, just to make the multiplication between the two terms with, okay, x dot x dash plus xy, x dot xy is y, x dot x is, complement is what here, the x dot x dash is what, 0, because x is having the 1, then the x dash is definitely 0 only. It's a complement form. One's complement 0's complement 1. Okay, that's the, that definitely it will be becomes what here, the 0 only plus xy. The answer is what here, the xy only. Just to apply the Boolean postulates and theorems here. One more is there, x plus x dash y is there. Okay, just to consider this as the function x plus x dash y. Okay, this is to be what here, the, I have to consider the x as itself as the x dot x plus x dash. Okay, this is what here, the, we have plus x dash y is there. X dash x is the x only, x plus x dash is the x. Okay, then the x dash y, x into x is what here, we have the x only plus x dash is what, 0, and x dash y is there. Okay, then the x dash x plus x dash y is there. X plus y, third one, x plus y dash. This is to be solved here. We have the two terms here. We have the two terms with the two literals. We have to make the multiplication between these two terms. Okay, first. Okay, xx plus xy dash plus y xy plus y dash. Okay, xx is what here, the a dot a is what, a only, plus xy dash plus xy, y dash is what here, the 0. Then the x plus xy dash plus xy. Then the take the x as the common between the all the terms, y dash plus y. Okay, x as the what here, the 1. Okay, 1 is the y plus y dash is there. What, y plus y dash or 1 plus y is what here? 1 plus x is what here, the 1 only. Yes sir, x plus 1 is what, 1 only. So I take the 1 only. So it's to be considered as 1 plus x also, or else you can also write the y plus dash is the 1 only. Better to have the complete term here. 1 plus y dash is 1 only. Then the x plus 1 plus 1 is what here, the 1 only. So x is here, the, so I written the 1 plus 1 is 1 only. Then the 6 is there, x only. Then write the, take the next third one, fourth one, x plus y, x dash plus z, y plus z. Okay, this to be considered as one function. Okay, x plus y plus x dash z plus, sorry, y plus z. Okay, just I am applying the Boolean theorems and postulates here. Okay, so in order to make the first, to consider these two terms here, make the multiplication between these two terms. Okay, x dash plus x z, next x dash, sorry, x dash y plus y z, left leave it, y plus z. X dash is what here, the answer 0, x z plus x dash y plus z. Okay, then the y plus z. Okay, then make the multiplication between all the terms, x y z plus x z z, then x dash y y, then x dash y z, then the y z z. Okay, y z z. Okay, then the keep as it is x y z, then the x z z is what here, the x z only. Then the x dash y is what here, the y dash a dot is what here, the a only answer. So that x dash y is the y only, x dash y z, then the y z only, because we have the same variables. Okay, take the common things. Okay, common here in between these two terms, in this between these three terms. How many terms are common here? Yz is the common in between the four terms. Okay, in the four terms, yz is common here. In the three terms, yz is common here. Take the yz as the common between all the three terms. Okay, yz is common here. So I left with here the x only. I left with the x only. So that x plus, and also xz is, don't take, this is the xy is also don't consider. X dash yz is there, just to write the x dash. Okay, this is yz is there, just write the 1. Then I left with what here, the xz plus 1, here the xy is there. Okay, yz is to be considered. Okay, this is the x plus x dash is what? Okay, this is 1 plus, this is similar to 1 plus x is what here, the x plus 1 is equals to what? Answer? X plus 1 is what? X, huh? Yaudu? YYZ is there. Okay, YZ I left keep here. YY? One more is there. YY Z. And I left it to the YY. I take the one more common YZ is the 1 plus 1. Okay. YZ would be common here. So among the three terms, x plus x dash plus 1 plus 1. Okay. Huh? Y is there. Y is there. Okay. Then this is what here, the xy. I left it what here, the xy, na? Y plus z. Okay. Then the yz would be here. X dash is what here, the? I can make it what here, the? I can write the 1 plus x dash plus y. Okay. Then the y plus z is there. Okay. Yz. Okay. This is to be similar to what here, the answer? X plus 1 is what answer? X plus 1 is what here, the? X only. X plus 1 is what? Yes, sir? X. Okay. I make it as what here, the x only. So I am considering this was to be what here, the answer? Common terms पे करता हूँ 12. Okay, just to take this one, 1 plus 1 plus y. Okay, this is to be what here, the y plus z. Okay, yz would be here. Then the 1 plus 1 is what here, the 1 only. 1 plus y plus x yz. Yz would be here, the 1 plus y is there. What is the answer? 1 only plus x y plus z. Then the yz plus xy plus xz. Okay, this is the final answer. So they will not see the final answer, but whether you applied the rules whether properly or not, they will see. They will check. Okay. In the last year I went to valuation. No, there we have not seen but the procedure whether you applied the consuming. Okay, but it's limited to what here the variables. Then I can't do the simplification of the Boolean functions with the Boolean theorems and the postulates. So that's what I will go to the what here the K map is there. One more is there. Pin McLeod method is there. Okay. Common here yz, and also yz here. Okay, yz is the a plus a is what? A only. So that I will take the only 1. Among the two terms, I will be consider as the only one term, that is to be a plus a is what? A only. So I will be taking the yz itself as here. So that I will be consider the yz itself. So that yz I will take the consider as the 1 because the common here. I left with here the x dash y and xy. Sorry, xz is common, x is common, z plus y dash. Okay, right? Okay, then the x plus x dash is what here, the complete term is to be what here, the 1 plus x is what here, the 1 plus x is what? X only. 1 plus x is to be considered as the x plus 1 is what here? The x only. Yz x plus x dash, because the I'm taking consider the x plus x dash itself as the x. Okay, complete two terms. Here's one. Yaudu? One more is there? Where? Illada? Ida? Idada? Why da? Okay, which one? Here? Yz? This side? X plus xz is there. Yz is common here. Yz, 3 z's are there. Let me write once again. You are asking me to without skipping anything. Okay. X, y, z is there. Plus one more yz is there. Yz plus yz is there. Az, yz itself I am considering the two terms. Only one term. Okay. Then I left with the x dash y. X dash yz. X dash yz is there. Then the xz x dash y. Xz x dash y is there. Yes, sir?
Yes, sir.
Okay. Then I am taking the yz as the common term here, so that I can write the x plus x dash plus 1. Okay. This would be what here? The xz plus x dash y is there. Completely I am considering this is as the 1 only. Okay. 1 only. 1 plus x is what? 1. 1 plus 1 is what? 1 plus x is what? 1. Yz considered to be 1. Xz plus x dash y. This is what here? The x plus x dash is what here? The x only. X plus 1 is here what here? The answer? 1 only. Those are I have taken the complete term as the 1 itself. Then I left with the yz plus xz plus x dash y is there. This is the final answer. They asked in the examination. Okay, I don't have solution, but you should have to apply the Boolean theorems and the postulates completely. Okay, somewhat tricky this one. We are unable to solve the V1 with the 3 variables also. If I have the Boolean postulates and theorems can be applied to how many variables? Only up to 3 variables. Only up to 3 variables. If I go with the more than 3 variables, then I can't solve with the simplify the Boolean functions and the theorem. These Boolean expressions are Boolean equations with the Boolean postulates and theorems. So that I will go to the better. One more option is there. That is that K-map. Another one is the Quinn-McCleskey method. K-map will be solved with the up to the 6 variables. But for your syllabus, we have the only to the 4 variables, up to 4 variables. Nimdo syllabus alli DDCO subject alli only for the 4 variables ge matra K-map ide. Other 5 variables ಮತ್ತು 6 variables I can also solve here, but the thing is that only 4 variables ಗೆ ಸ್ಟಾಪ್ ಮಾಡಿದಾನೆ. ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದೇನ Quinn-McCleskey ಮೆಥಡ್ ನಿಮಗೆ ಸಿಲೆಬಸ್ ಇಲ್ಲ. ಓಕೆ, ವಿಲ್ ಗೋ ವಿತ್ ದ K-map. ಓಕೆ, ವಿತ್ ದ K-map simplification with the up to the 4 variables only. Okay, up to the 4 variables only. Okay, just to consider the K-map. Next topic is what here? The K-map. K-map is nothing but the one of the grid. Okay, grid solution. This is what they are the K-map. Carnot map. Okay, K is nothing but the scientist name Carnot. Okay,